Welcome everybody to the next HORIBA webinar from Willie Hendrickson with AVEKA. He's going to be talking about leveraging a research budget through IFPRI, which is the International Fine Particles Research Institute. Willie, take it away.
All right, thank you, Jeff. Jeff just introduced me as Willie Hendrickson, the president of IFPRI, or of AVEKA, and I am the president of a company that does contract manufacturing, but I'm really here today to talk to you as Willie Hendrickson, the president of IFPRI. So Jeff, you led him a little bit astray, but I think we're back on track now.
Okay, I apologize for that.
Well, when you wear two hats, sometimes it can be confusing for everybody. Today I'm going to talk about leveraging a research budget through IFPRI and just what that means. What I'm going to do in the talk is I'm going to give you some ideas of why this would even be important. I'm going to give you an overview of IFPRI itself so you kind of understand what the organization is. And then at the end I'm going to go through some specific examples that I think are unique to IFPRI that can actually help you be a better researcher, a better person to understand particle technology. So with that, let's go to the first slide. And this is a slide that I really like to talk about, is why is science, particle science and technology important? Because as most of you know, there's not too many people in the world that actually have a particle science and technology degree. There's just a very few handfuls of degrees that are in this area, and all of us are probably mostly material scientists, chemists, chem engineers, industrial engineers, mechanical engineers, and we're not taught particle science and technology in school. We kind of learn it on the job. But the issue about why this is important is particle science and technology affects just basically all industrial manufacturing. When it really comes down to it, it's ubiquitous, it's everywhere, and here it is, we're not really prepared for it when we come out of school as a chemist or an engineer. And you know what's even worse about this, and we find this out as we're starting our careers, is we have a particle in our process, and small changes in particle related aspects or the process itself can have huge effects on the productivity and profitability of the product that we're trying to make. So here's an area that is everywhere. It's not as understood as it could be. It has big effects, and so this makes it a very important area and one that needs as much help as it can possibly be. The third point on this talk is if you are in product development or in manufacturing, particle technology is never the focus in development. It is always an afterthought. And so the only time that particle technology becomes important to you is when your bin or hopper won't unload, or the product isn't doing exactly what it's supposed to do. And at that point, now you're kind of looking like, well, what the heck am I going to do? So here's some examples of what I consider just absolute traditional particle technology challenges that people face day in and day out. A lot of times is, how do you get that powder to flow from a hopper? I mean, that's not something that you try to design to make that hopper right to start with, but it's not necessarily something that you've spent a lot of time focusing on because you've got something else to worry about. When people are mixing two powders together, many times during handling, powder segregation can happen, and if you're trying to deliver a uniform blend to whether it is to your customer or to the next unit operation in your process, that powder segregation is just one of those things that you're typically not prepared to handle. If you're taking powders and putting them into liquids to make slurries, whether it's inks or gravies or sauces or whatever it's called in your particular industry, small changes in particle properties and small changes in concentrations or pH or I mean, I swear to God, sometimes I feel it's the phase of the moon, can have huge effects on your slurry properties. I see it many times that we always think that we have the right raw material and the next lot comes in and it doesn't work right. Many times it can be there's a change in the surface chemistry, but many times it's something as simple as you'll get a particle size variation. It might still be within the spec of what the vendor is supplying you, but it's not the same, and so it operates a little bit different in your system, and so now you have another challenge. And one that I'm particularly involved in is what happens in drying, whether it's a spray drying process or a tray drying process or a tumble drying process. It always seems like I'm scratching my head as it worked so well yesterday. Why is it drying slower than it did before? So these are the sorts of challenges as you've gone through, done your development, started to scale it up, got your product working, that all of a sudden will show up, and they'll show up for a time and maybe go away, or they'll just get worse and worse and worse. These are the challenges that I think that everybody can use some help, and these are the challenges that some of the things that I want to talk about. So when I go to ask the question, I've got a challenge, whether it's whatever one of my processes are, where do you find the expertise, suggestions, or answers? And if you're in a big corporation, if you have a corporate engineering function, there's usually somebody there that might be able to help you. Some companies like DuPont, for example, have a great corporate engineering function and have a great history of having particle technologists there to help the entire company. If you don't have that, or the corporate engineering doesn't focus on particle technology, always the first choice or the second choice is to go to the academic literature, and that's a great place to go. But many times in the academic literature, the challenge of how to make that powder flow better, or how to keep it from segregating, might be less easy to find in the academic literature than you'd really like, or that the answers aren't exactly germane to what you're trying to figure out. But yet, it's a great source. We all like consultants, or we hate them one way or the other. I mean, they have their purpose. Great consultants can be a fantastic answer for you in particle technology. And then, of course, there's the internet. I mean, the internet, what a wealth of knowledge, and the answers that I can find there on a regular basis are huge. But what I've found over all this time is that even with all of that expertise, whether it's corporate engineering or people in your company that can help you, or the academics or the consultants or whatever, there are times that some of these problems are still very, very hard to come up with. And how do you find the answer to get through to that next step? Well, what I'd like to say is IFPRI is going to help you with that. And what I'm going to do now is I'm going to give you just a little background on IFPRI, and then you will get to some of those ways that I think that IFPRI can actually help you with your development and your scale up and your manufacturing challenges and processes that you have. So IFPRI itself was started in 1979 by 5 professors, international professors. Bob Pfeffer was in the United States, Kurt Lashansky was in Germany, Professor Anoya was in Japan, Brian Scarlett was in United Kingdom, I believe, at the time, and Frank Tiller was in University of Texas. And these professors were really leading their areas in particle technology, and they realized that there was a gap between what the academics might know and understand about particle technology and what was being actually done in industry. So they were talking at a meeting one time, and they said, let's contact some companies and see if there's an interest in forming a consortium to look at particle technology with a focus on industrial applications. So they called up a person at DuPont. Actually, the person at DuPont, isn't that terrible, Howard Turner, said, I think that's a great idea. Let's get some companies together and see if we can put together a consortium to do this. So in 1979, the professors and representatives from these 12 companies got together and said, yes, we need to have some forum for exchanging ideas and talking about what's important to industry that we don't seem to have right now, and they set up IFPRI. interesting part here, and I just want to point out, when you look at some of those original companies that were there, Bethlehem Steel and U.S. Steel, even though they're in direct competition with each other, they found it better to be talking among each other about what the issues are and how they solve them than trying to ignore it, because particle technology, once again, is one of those extremely difficult areas, and the more talking and interaction you can have, the better off it is. So the original observations that the members and the professors came up with is, and this is 1979, and some of these things still hold true, is that there was a lack of fundamental particle science understanding. We've gotten better over the past 38 years, but there's still room for improvement. There was a lack of a forum for intercompany discussion. And when you think about that, the problems that you're having in your company are probably happening in another company. How would you ever talk to somebody in another company in an appropriate manner? Hopefully IFPRI was going to address something like that. And then finally, and this was the professor's original thought process, is there's this poor connectivity between universities and industry in this area of particle science, and specifically the universities didn't necessarily understand completely what were the issues that were driving industry. University professors, have many answers, but if they're not looking at the right questions, that can be a difficult challenge, and a difficult challenge to overcome, because once again, how do you understand what is very germane to what industry wants? So the mission that came about because of these observations is IFPRI is going to be a place to provide a venue for particle technology discussion. And we're going to talk about this a little bit more in the talk, but this is a huge part of what IFPRI does, is bringing academics and industrial people together for a good period of time once a year to have these discussions about particle technology. Secondly, the idea is the industrial people know what's bothering them the most, so let's develop a strategic plan for particle science, and that's something that IFPRI has been doing for the last 38 years. And finally, as opposed to many consortiums, it's the industrial members that actually direct the R&D focus for industrial concerns. So it's not the academics trying to lead the industrial people. It's the industrial people saying, nope, this is where we want to go, and this is what we want to focus on. So over the years, what IFPRI has done is they've developed a technical program, schematically shown here, that involves 5 separate areas. Core to this is the ability to measure and characterize your particles. So many years ago, and 38 years ago, some of the techniques that we take for granted, such as zeta potential or complex rheological measurements, or even some of the dynamic light scattering methods, were not known or very just in the nascent stages. There's been a lot of focus on, let's make sure that we understand better and more ways of characterizing and measuring our particles. This is a key part of IFPRI. The other 4 areas that are around the periphery of this this diagram: dry powder flow. Does that mean powder flowing out of bins and hoppers, or does that mean pneumatic flow? And the answer is yes. I mean, these are both parts of the IFPRI focus on particle technology. Size reduction, many different ways of size reduction, whether it's jet milling or pin milling or cryogenic milling. These are all things that IFPRI has looked at over the years. Particle formation is another area that's very important to the IFPRI understanding of or view of particle technology. And finally, the last one on here are particles in solutions, whether they're sols or dispersions, and how do those flow, or how do they separate, or how do you separate water from a particle water or particle liquid dispersion. This kind of builds up the structure of the IFPRI technical program, what we're looking at. And the interesting thing is, you can see some of those arrows that go in between the arrows, or in between the boxes. the transition from wet to dry, either adding liquids to powders and making a slurry or taking a slurry and drying it. These are all parts of the, the bigger picture of particle technology. On our next slide here, this is an example of, well, this is not an example. This is the actual program that IFPRI is funding for the year 2015 to 2016. And so you can see in the second column are the technical areas: characterization, formation, wet systems, size reduction, and dry systems. And the first part of this, the top of these this slide, are the proposals that IFPRI has decided to fund. And so, not to go through each and every one of them, but there's a new project that Uli Wiesner at Cornell University has started on molecular self-assembly. Basically how to make particles by using self-assembly methods, or the project that Charlie Wu at University of Surrey is doing of dye filling of aerated powders. And once again, without going through and reading all of these, the idea here is the members have come up with, these are projects that are important not to just one company, but to many companies. And so everybody is getting, a chance to contribute and ask for research that they think is important. And at the end, the members vote on these, and these are the current programs. Now, if you see on the last two columns, projects at IFPRI last for 3 years. So, as an example, we'll go up to Miguel Quintela's project at University of Seville up at the top, the effect of electrostatics on particle packing. We started that project in 2014, so there's 3-year funding for 2014, 15, and 16. We'll decide this year whether we're going to renew that project, and if we do, there will be 3 more years of research and development going on after that. At the same time we have these full proposals, we also every year commission a number of reviews, and it can be anywhere from 2 to 4 reviews. And these reviews are on areas that the members are interested in also. Not ready for a full proposal, but want to have somebody give them a review of the area. So at the bottom, there's 3 systems reviews that we have for this year. A deliquoring of solvent wet cakes that's being done by Harold Onloff at Karlsruhe. A formation project is the sticking of powders to equipment surfaces, and it's really quite an interesting system. Is how can we keep the powders from sticking to surfaces so we can empty out our bins better or empty out our feeders better? And finally, a size reduction is what happens to powders from structural and surface transformations during milling, being done by Marc de Camp at University of Lille. So the idea, once again, is to have some good projects. They change year by year. We have reviews, and many times out of the reviews, we'll have a new project that's developed that comes on, that comes up for the next year as a new project. The industrial membership that's currently in IFPRI is shown on this slide here, and you can see there's actually 26 members. There's full members up at the top and associate members at the bottom. HORIBA and AVEKA are associate members, which means that we are small companies and not capable of not capable of having the full fees that a large company would have. But you can see the large companies range from companies like Procter & Gamble and Unilever to companies like Johnson Matthey or Merck or DuPont or Syngenta. It's a good broad range of companies that are international in basis. So companies like a Corbion over in Europe, or a Nippon Steel in Japan, or a Procter & Gamble in the United States, we're kind of trying to cover the entire world to make sure that there's a good representation all around. One of the things that we hope is that some of the people that are listening to the talk today will have some interest in that, and I will be sending out a separate questionnaire to you, or a flyer to you, asking about your interest in IFPRI. But hopefully you'll answer that and be very excited about what you see here. The deliverables from IFPRI range from annual general meetings, and we'll talk a little bit about that. This is our 5-day annual meeting that we have, to 10 to 12 annual research reports. We have a library of 600 commissioned reports and reviews that are IFPRI member only available. But down at the bottom are the three things that I really want to focus on this talk about how IFPRI can help you with your leveraging your research budget. And these are what we call workshops, roundtables, and intensive technical interaction. So let me explain what these three deliverables actually are. So a workshop, about every other year, the members get together and decide we need to have even a more concentrated time to spend on one topic, and we call these workshops. So they'll typically be 2 or 3 days long, and I'll describe them a little bit more, but it'll be an intense focus, and why this will help you, I hope to show you in a second. Roundtables are what we do, where we have maybe a half-day roundtable discussion on a specific topic. These are what we typically call best practices discussions. So what's going on in the industry? So what's going on in other companies on how do they handle this particular area of particle technology? And finally, in between the annual general meetings, the phone conversations that we have are, meetings outside of IFPRI. IFPRI fosters and encourages intensive technical interaction. These are things that you'll get much more knowledge and feel about the general scope of the industry from talking to experts in the field much quicker than you could get perhaps from reading reports or going to listening to academic talks. So the annual general meeting, I'm going to come back to the other three in just a second, but the annual general meeting is held around the world. In 2014, we held it at University of Edinburgh in Scotland. Last year was at Cornell University, and this coming year, our annual general meeting will be at the University of Surrey, just to the southwest of London. Typically at our annual general meeting, we will have particle technology reviews. So those reviews that we've asked for, that I showed you 3 or 4 slides ago, the professors will be there to give us reviews. We'll have project overviews. We will decide on what the next opportunities for proposals that we'd like to get. We call these project brief writings. You get together with the other members that are at the meeting and break up into small groups and come up with ideas that we should fund. We have a seminar series that we've named after one of our founders. We have student poster sessions. We have quite an interesting proposal and brief voting for what's going to be funded for the next year or what we're even going to look at. And finally, we have a few business meetings. This all happens in the span of 5 days. This is intensive work. We often have to tell our management that we are not going to a conference to relax. An IFPRI meeting is a conference to work very, very hard at, and we like it that way because it gives us a chance to, become better particle technologists. As I said, our next annual general meeting will be at the Horsley Conference Center just outside Surrey in the United Kingdom. It's going to be June 12th to 16th, and I hope some of you can actually make it there. Once again, I will be sending out some more information to each one of you after the meeting, or after this talk. Excuse me. So let's talk about a deliverable example, one that specifically can help you in your maximizing what sort of benefits that you can get out of IFPRI for your development or scale up or manufacturing. And this is a workshop example. So 3 years ago, excuse me, we did a workshop on particle formation. And what this workshop entailed were 2 days of technical overviews We'd have a breakout session to talk about what was going on. We would build consensus. We would go back into another technical overview, and we would do this kind of repeatedly over 2 days. What happened when this was all done, this idea of consensus building of what were the important areas in particle formation that had broad applicability that could have, you know, big effect on the particle technology community, we actually came up and wrote up a number of program proposals. And what came out of this meeting, this particular one, where there were 2 defined areas of interest. One was, could somebody just make a standard particle? And think about that for a second. If we're all trying to understand flow properties, and I'll just use this as an example, wouldn't it be nice to have a big box of the particles that were exactly the same from one particle to the next, so everybody could be given these particles and we're not now looking at variations in surface chemistry or size or shape, but actually make a standard particle that could be used for measuring particle flow or drying conditions or slurry rheology. This was one area that came out of this, and the second one was this idea of best practices. And the idea, the best practice idea was, well, so all these particle formation ideas that we have, but what's the best way that people handle these in companies? What are the best practices? You know, and no one really had an answer to that, and it seemed an area that we should be looking at very carefully. So out of these 2 areas in that annual general meeting that followed this workshop, there was a project brief that was written to ask professors to come up with a method to make a standard particle. From that brief that was sent out, we received 3 proposals, and at the end of that, we voted on funding Professor Karen Hapgood at Monash in Australia on making particles by 3D printing. And so what Karen is working on is making particles of different sizes and shapes using 3D printing that she will now make quantities of these to pass them out to other people to now start measuring the powder flow or the drying or the slurry rheology. And now we will always know that we can make the same particle again and again and again, and it won't be an issue that are we really looking at the particle variations, the chemistry, the size, the shape variations, or are we just looking at the particle itself variation? So Karen's project was, I thought, a great outcome of this, something that if we now all had standard particles to understand the theories better on whatever thing that you're looking at, maybe we can actually make this a much better way to improve the research of everybody on this. And so the idea of this workshop, I thought, had a great merit. Not only did we have this opportunity of this one research project coming out of this, but the idea of gathering the leaders in the field in particle formation and talking with the industrial people on what they really needed. I thought the industrial people came out of this well ahead, because it was a tremendous thought-provoking opportunity for everybody that attended. Last year in Ithaca at Cornell, we had another workshop, and this one was predicting the crystallization behavior. And you can see that the speakers that were invited to this, you know, it was really some of the big names in the area of crystallization behavior. We had some other participants in here, and then we had about 25 industrial people that were working on this very hard. And once again, from a standpoint of my own personal growth, you know, I learned so much about crystallization that even though I'm not a crystallization person, I felt like I took home much more information that enabled me to do better on just handling particles in general. So these workshops come up about every other year or so, and they've been a great help. The other thing that I think can really help you in your day-to-day work are these roundtable discussions. And remember, a couple slides earlier, we said out of the particle formation, we decided that we needed to have some way of discussing best practices. What came out of the best practices was an idea of let's have a roundtable discussion about specific areas. And so the first one that we had was a roundtable on shear testing of powder flow. And the idea being is that everybody tests powders for flowability in different ways. How do you do it? How many samples do you take? You know, how are the tests done? What are the devices that you use, and how do you analyze the system, the measurement? You know, imagine that, you know, no one was talking about proprietary technology because that would be inappropriate, but just all getting together to talk about this is how I handle this, this is why I do it this way, this is the type of results that I'm looking for. The light bulbs that went off around the room, you know, again and again and again, is people would say one thing and you could just hear somebody go, oh my God, isn't that a great idea? I should be doing that at my company. What a great way of maximizing your ability to do better in lab than be able to have a discussion with people in other companies that are struggling the same way that you might be struggling. Or they have the great ideas and they just like to share them because it's a great way of analysis, doing this analysis. We've done 3 of these roundtable discussions in the past year and a half. One was on the best way to do DEM analysis of your discrete element modeling analysis. You know, what were the best programs? What were the ways that you apply this from an industrial sense? And the third one that we just completed was measuring powder flow. What does it really mean? You know, it was a tremendous meeting. There was a lot of ahas that came out of there, things that people were able to take home about how I can do better in my process development and manufacturing. The conclusions that I'd kind of like to leave everybody with here, and I'm going to focus on the 2 in blue because these are the ones that I think are the real take-homes on how to become better in the processing that we're trying to do, how to maximize your benefits, is the academic associates at IFPRI are world-class authorities. And we haven't talked about the consultants that we hire from an IFPRI. We have 5 consultants, 1 for each one of the areas that we have. Plus the IFPRI members themselves are typically very high-level people in the area of particle technology. There is within IFPRI there is a group of easy to tap into consultants, excuse me, for particle technology. Secondly, the workshops and roundtables that focus on intercompany discussions of best practices and strategic plans for particle technology. Every time I go to one of these things, the amount of knowledge and insight that I take home to my own company and my job is absolutely huge. You know, the IFPRI itself provides all kinds of other great advantages, but those 2, I think, really are the take-home messages for me and the take-home message for this talk. And finally, I'd just like to leave you with a contact information. If you have any questions about IFPRI, you know, please call me or email me. And you know, thank you very much for listening to my talk.